Okay, so let's do quickly because 10 minutes. Anybody would like to share? Should I start the first one? Do you think we should use this or? Oh, this one also is cosine theta, right? There are four. So there are four identities for cosine. See, all four are true for cosine. So this time, what do you have here in this case? There is a sine and there is what? Cosine. So which one has sine and cosine? Is it the first? Is it the second? Is it the third? Or is it the fourth?
First and the third.
But if you say first, there is a 2 theta here. This is theta, right? So you want to have, you want to like pick only the one that has.
I think it's the second one.
Who said? Okay. I think, and why you're thinking? Because you see that two theta here, and there's a theta here, but there's a cosine square here. But with the formula we have sine here.
It's because 1 minus cosine squared equals sine squared. And I think that's where the square root comes from.
Okay. The square will be the last part. Just think of before that. Okay, let's put it like this. If I have 5 minus 5 is 2 minus 3x. 3x squared. How do we solve that? So what is the first step you do? Subtract 2, right? Subtract 2 both sides. Then what else? This is 5 minus 2, right? What's the next step? Divide by negative 3. Correct? So this will go, correct? So you get x square is, you left with this part, 5 minus 2 and divide by negative 3. And then you put a square root, right? Do the same thing, but the problem is which one to pick. Anyways, I like you are thinking different. Each one of you must be thinking. It cannot be this. Of course, there's one of these three. I'll pick this one. Let's see why. Otherwise, we are heading to the right direction. So let's pick up cosine 2 theta is 1 minus 2 sine square theta. Is this okay so far? I picked this one. So this is double angle formula, I picked this. And I do like exactly like what I did here. So first subtract. What do you subtract first? Do you subtract 2 or do you subtract 1? 1, right? It's like that. See how this is? So in this case you are subtracting 1. So subtract 1. So everything stays the same. Cosine 2 theta equals minus 2 sine square theta. Agree? Then divide by. So divide negative 2. I think I missed here minus 1, right? So now divide by. Is that okay? So this minus 2 goes away, something like that. See, minus, there it was minus 3, minus 3. And when you have a negative, say, I want to, because this minus sign is like, we don't want to have a minus. The only thing is you can always swap this. So it is, if you have 3 minus 5 and there is a minus down, this is always equals to 5 minus 3. Just take note of that. So sometimes we get confused. It's better to write this so that you want to get away with the negative sign, just it's same as 5 minus 3, just swap it. So instead of 3 minus 5 changes to 5 minus 3. You can always check. That's possible. So this cosine 2 theta minus 1, we can write it as 1 first, and the cosine separate, and divide by 2, this minus 2 is 1, and you're left with sine square theta, correct? And now you take the square. That's the last step here. So these are also called trigonometric square trigonometric identities, square trig. So if you write this one, that's called square trig identities. Means sine square is always 1 minus cosine. So you can remember this is a beautiful form where sine square is always 1 minus cosine 2 theta divided by 2. Okay, so instead of writing this, let me rearrange this. So sine square theta is 1 minus cosine 2 theta divided by 2. If you remember, there is in the integral calculus you have suddenly you come across what is sine square of x dx. Do you remember this? You were there, right? Cal? No?
It looks familiar, but I
Yeah,
don't remember.
the integration we do, and what is the integral of sine square? There's no formula for integral of sine square, but we can always change this to, okay, now that you know 1 minus cosine 2x dx over 2, and then you say separate this because divide by 2, take it outside, you're left with this. Integral of 1 is, whose derivative is 1, and you say x. Do you remember the derivative of x is 1? And minus, whose derivative of cosine is sine 2x. But because there is a 2 here, so divide by 2. So my point I'm making is when you go to the university, there will be a lot of this kind of stuff, and now you want to know why it is. Got it? So the sine square is 1 minus cosine 2 theta. Make sense? So don't worry, if you get, this is just those of you who were in the calculus class, and sometimes not only sine square, it could be cosine square and tan square. So I think I should not have put this box right here. I think I should have put box this is that square trig identities. Okay, and then what Jaslyn is saying, Ribello, let's put that. See, and then he gets you over that thing. So your answer is sine theta. If you just want to write sine of theta, it's plus. And remember, when you want to get away with the square, it has to be not plus, it has to be minus. 2 answers. Remember, if you have x square is 9, most of the students they say, oh, the square of this is 3. Do you agree with this? Where is the mistake?
It could be either negative
Yeah,
or
it's not just plus, but it's also minus. So there are 2 answers here. X is plus 3, and what else? So that's what I'm trying to say. I mean, just to get the concept clear, why we write plus and minus. So this is plus and minus square root of 1 minus cosine of 2 theta divided by, and that's what the half angle formula for sine. Just to give you an idea, before I just go, we are going to work on this lot. If I ask you what is sine of 15, example, without using the calculator, can you tell me what is this one? Answer? I want you to focus here on this. I want you to focus here on this red theta. Theta is anything, what is, basically theta is just an angle. So this is some angle here, but that angle is, a number is multiplied 2. Do you see that? 2 is multiplied. Now 15 degrees, which quadrant are we on? Where is 15 degrees? On the, correct? Do you see that? So that's in the first quadrant, everything is positive, right? So answer has to be positive, agree or not? Now there's a square root, do you see the square root? 1 minus, there's a cosine. And what is 2 times 15? 30? See how it works now? It's like you already know 30, but they are asking you 15, so you just have to double that and divide by 2. And what is cosine of cosine 30. Correct? Agree? So in a way is we are just working with that kind of thing. So to apply half angle formula is if there is anything is given, you just have to use this 1 minus cosine. Is that okay? Okay, so now this we did, let's do the second one is y sine. So the next one is y cosine. Can you write quickly? Cosine is, that's it. So we want to know why this. And let's do that also. So which formula should help us this time? Now what should I use? So y, the second question is y cosine length, right? So what should I begin with?
Mr. Wood, inside the square root be 1 plus sine squared here. Or was the
Here, I want you to use one of, now we use, last time we used this, correct? And in this identity you see there's a theta here, there's a 2 theta, correct? Both cosine should be there. So there should not be sine. Got it? So this identity does not have sine. So what should I begin? The first one has got sine square and cosine. So the second one. So you can decide what. So we'll begin. Let's use. So I'm gonna use. You want to know why? This is a question mark. Why the hell this is exist? So we'll start with, hey, we know cosine 2 theta is 1 plus, sorry, it's 2 cosine square theta minus 1. And you are supposed to remember this, right? It's so difficult, right? So sometimes you say, oh my God, so many formulas, so many identities. How do you remember all this? So what you do next is just add 1 both sides. Okay, let's do that quickly. So add plus 1 both sides. So add plus 1, add plus 1. This is easy. We don't have to spend too much time. So this is why I'm going to write plus 1 first and then plus cosine theta equals 2 cosine square theta divide by 2 both sides, like how we did previous one. So this 2 goes away and you're left with cosine square, so I'll write cosine square on the left side and this on the right side. Divide by 2. So this is the formula square trigonometric identity for cosine. So cosine square can be always replaced by that one. So once you get this, so cosine square, then we can say, okay, cosine theta is plus minus 1 plus cosine 2 theta. You see that? Done. So your question will be, can we do one example on this and say, let's see if I ask you what is cosine of 22 and a half, let's say. Can we figure this out? So that's the formula which should help you this to figure out. Natalia, can you try? So how should I write this?
Plus or minus.
Should we write minus here? Which quadrant is this? Where is this angle 22.5?
Can be positive.
So it's going to be positive because this is the second quadrant, agree? Oh, sorry, first quadrant. First. So in the first quadrant all are positive. Put a square root and what is the formula there? 1 plus cosine 2 times 22.5. So what is the meaning of 2 times 22.5? Please.
45.
2 times 22.5, right? So you are doubling the 1 plus, and that is 22.5 is multiply 2, you get 45, right? Agree? Can you take note of this? I'm also hungry. Okay, so what is cosine 45 then? Root 2, forget, right? You forget, Mr. Rebella, we don't know. And then because there's a 2, we can always multiply 2 and divide 2. So that way, that becomes 2 plus root 2 divided by 2 and again divide. And you can do keep change flip and this will be 2 plus root 2 and divided by 4. You can work it out and use the keep change flip thing and get the answer. So the last one is y tan theta is plus minus square root 1 minus cosine 2 theta. Can you write this? The last one, and we are done for this. And then we go back to that 7.2 homework, the packet that we did. We had done some of this problem. There was no time, right? So we'll do those also.
We would use the class 2.
Yeah, we could use the direct, now that we have seen, what was that? Remember we did sine theta was plus or minus what? 1 minus cosine 2 theta divided by 2, agree? Then what was cosine theta we did? We seen plus minus 1 plus, is that okay? And you kind of just do divide this. So let's write that. So this is the left. Yeah, correct. So tan theta, the left. This is the left. Tan theta is, we'll use the sine theta divided by cosine theta. And each one of them is square root of 1 minus cosine 2 theta and divided by 2. This was 1 plus cosine 2. I remember last time I gave you the trick. If you have both these two, they can be put under the same one common radical sign. Like see 1 minus cosine 2 theta divided by, and then again 1 plus cosine 2 theta. Do you see how it works? I went a little fast. I hope tan is sine over cos. And sine, we just replace those formula that we did today, which is square root of this. Of course, it is plus minus, and then we say plus minus. And then these two can cross out, so eventually you get 1 minus cosine of 2 theta. Is that okay? Nobody saying this. Correct, right? So what I did was I replaced sine theta formula right here, cosine theta formula here, and if you have a radical numerator denominator, you can put a radical of the both. This is like an undo distributive property of radical, and you can write like that, and that's what you get. So you may have a question as, how could we use this? How does this help to figure out? What's this? Suppose I'm asking, what is tan of 15? Can we find out? So you can use the same formula, Jaslyn, Hugo, but what do? You put a plus. Of course, 15 is, it has to be positive, and just replace 1 minus, what is double of 15? So it is, so both 1 minus cosine, 1 plus cos, but what are the angles now? What is 2 times 15? So this is like 2 times 15, which is 30, agree? And we do know what is cosine 30. So cosine 30 is root 3 over 2. Agree? Yes or no? So I'm just to do a regular thing. What I'm trying to show you is, this is easy, only because the radical sign you may have a little confusion, but eventually, because we are going to do a package more on a lot of problems on this. Okay? So I'm focusing only why the hell these formulas agree. So if you wanted to really do this work, you just multiply 2 like this. See? So you have the same common denominator, 2. And the top one will be 2 minus root 3, and this is 2 plus root 3. And then you just cross out this, because both denominators are the same. Is that okay? Done. So the goal was how to prove this, okay? How to prove the half angle formula. And I want to extend this also beyond it. So the question is, can we rewrite, right now, can we rewrite half angle formulae? What I'm trying to say is, now that you know sine theta is plus minus square root of 1 minus cosine, well, I'm going to use this one. So let's use the square. Sine square theta is 1 minus cosine of 2 theta. Cosine square theta is 1 plus cos 2 theta, and we have seen tan square theta is 1 minus cosine 2 theta and 1 plus cosine 2 theta. So I put this in the box. Of course, the formulas are in terms of sine theta with the root sign, but this is important, and I want to rewrite this also as, if you have sine square theta by 2 like this, all you do is double of this is just a theta. So it is just writing the same thing. It is the same thing. The only change is, instead of theta, watch this. This theta is replaced by theta by 2. Do you see this theta by 2 here? So divide by 2. So if this side is divide by 2, it's just a regular theta here. So that's the confusion, but because many identities you come across like this, where you replace one sine square as 1 minus cosine 2 theta. These are square trig identities, which also is written in the half angle formula. Remember the half angle formula, how did we write? From this tab we got sine theta is plus or minus square root of 1 minus cosine 2 theta divided by 2. Cosine theta is 1 plus cosine 2 theta divided by 2. And tan theta is plus or minus 1 minus cosine 2 theta is 1 plus. Too much, right? Too many things? Watch this again. This is another way to remember that sine square can be written as 1 minus cosine 2 theta. Or this and this is the same damn thing. Only thing is, if it is divided by 2, there won't be 2 here. Do you see this? Here there was a 2. Do you see there was a 2 here? Because it's like from right to left it becomes half. From left to right becomes double. Do you see what I'm saying? Are you with me? No. Jaslyn, what did I say? From left to right it doubles.
Yeah.
From right to left it half. So that's why if it is half here, that's the double of that. It's a little tricky there. Anyway, so wanted to show this, and now can you take out your packet 7.2 and we'll continue with that. And see which problem we were doing there?